Now another topic in unit 4 is armature reaction in alternator. So what is the armature reaction? These are very important. So the armature reaction normally in DC machine also, but in alternator that is different. So armature reaction in alternator is defined as the effect of armature flux on the main flux produced by the field poles. Normally there are two fluxes, armature flux and main flux. So main flux for the stator winding, armature flux for the rotor winding. So normally the rotor winding is excited by a DC supply in synchronous generator. So the armature reaction in alternator is defined as the effect of armature flux on the main flux. So when we produce armature flux due to the DC supply, this will be affects the main flux. This process is called armature reaction. Armature reaction at unity power factor load. Unity means cos phi is equal to 1. Both voltage and currents are in phase in unity power factor. Please see the phasor diagram. The current and voltage or current and flux are both are current and voltage both are in phase. Flux also in same direction. This is a pi of which is the called main flux. So the flux of armature flux and main flux at an angle of 90 degrees in unity power factor. Please observe the phasor diagram. So as you can see from the waveform that the armature flux will cross and distort the main field flux at one point, thereby weakening the main flux. This is to be a cross magnetizing effect. So the unity power factor causes cross magnetizing effect. Armature reaction at ZPF lagging load. ZPF means 0 power factor lagging load. Please see that one. So E phase. So the current is 90 degrees from the E phase. This is a main flux. And armature flux both are anti-phase, means 180 degrees anti-phase. So main flux here, armature flux here, both are anti-phase. Please see the waveform also, both are main flux and armature flux both are anti-phase. Thus the main flux gets decreased in this loading condition. This affect the armature reaction on this load is said to be demagnetizing effect. Due to this, the main field flux gets weakened and so the EMF induced will be reduced. Armature reaction at 0 power factor leading load. So in leading load, the E phase here, both armature flux and main flux are in same direction. Please observe the waveform. The armature reaction in this load is said to be magnetizing effect. Due to this effect, the main field flux get weakened and so the EMF induced will be reduced. For any intermediate power factor, the effect of armature reaction in alternator will be partly distorting and partly demagnetizing. When an alternator supplied a load at the unity power factor, the effect of armature reaction is cross-magnetizing. The effect of armature reaction is demagnetizing when an alternator supplied a load at lagging power factor. When an alternator supplied load at the leading power factor, the effect of armature reaction is magnetizing. When an alternator supplied a load at the intermediate power factor, the effect of armature reactor is partly distorting and partly demagnetizing. The effects of armature reaction may cause the generated EMF to vary. In order to overcome that one, the main flux is varied to generate the rated voltage. After completion of this chapter, student able to learn voltage regulation methods, EMF method and Mmf method. So this is a voltage regulation is a very important topics. For finding voltage regulations, we have different methods. That is a EMF method or Mmf method, ZPF method, ASA method, short circuit ratio method, two reaction theory, phasor diagrams, determination of XD and XQ for slip test. So the first, what is meant by voltage regulation? The voltage regulation of an alternator is defined as the change in terminal voltage from no load to full load. The speed and field excitation being constant divided by full load voltage. Voltage regulation is equal to no load voltage minus full load voltage by full load voltage into 100 is nothing but voltage regulation. There are several indirect methods of determining the voltage regulation of alternator. Those are synchronous impedance method or EMF method, Ampere turns method or Mmf method, zero power factor or Portier triangle method, American Standard Association method. Now we discuss the synchronous impedance method or EMF method. So what is the synchronous impedance? So synchronous impedance method or name indicates EMF, electromagnetic field method. So assumption, saturation effect is neglected, armature reactance is considered as leakage reactance. Here the armature reactance is equal to leakage reactance. In this method, drop due to armature reaction or reactance flux phenomena is considered as leakage reactance voltage or EMF phenomena. Hence, entire drop is voltage phenomena. Hence, this method is known as EMF method. The regulation determined by this method is more than the actual value. Hence, this method is called pessimistic method. So, the regulation determined by this method is more than the actual value. Please see. For finding the synchronous impedance method or EMF method, we need to conduct two tests. One is open circuit test, another one is short circuit test. If you draw the characteristics OCC and SCC, we can easily determine the synchronous impedance method. So here this is a field current or excitation current. This is a open circuit voltage, this is a short circuit current. We draw all the parameters in single graph. By using graph, we can find out the EMF, synchronous voltage regulation of alternator. Next one is the Ampere turns method. So the Ampere turns method is an extension of EMF method. Here the both are same, but the finding regulation is different in graphs. So here also saturation effect is neglected, leakage reactance is considered as armature reactance, XL is equal to XA. In this method, drop due to leakage reactance voltage phenomena is considered as armature reaction. Hence, entire drop is due to flux phenomena. Hence, this method is known as MMF method. The regulation determined by this method is less than the actual value. Hence, this method is called optimistic methods. We determine the regulation is less than the actual value. So, please see here also we doing the same test OCC and SCC. From the OCC SCC curves, we finding the no load voltage E0 value. From that E0 value, we finding the regulation. The regulation of alternator formula is E0 minus V pace by V pace into 100. Next one is a Portier triangle method. That's also called as ZPF method. ZPF means zero power factor method. In this method, saturation effect is neglected, leakage reactance and armature reactance are considered separately. This method is based on the separation of armature leakage reactance drop and armature reaction effect. Hence, it gives more than accurate result. Here, we need to conduct under test, that is a ZPF characteristic test. First, draw the OCC characteristics. So, next draw the ZPF characteristics. Draw the tangent to the OCC, that is a air gap line. So, whatever the distance in OP dash, the same distance is maintained here. So, first taken the rated voltage from the point P, extend the, first identify the rated voltage on graph, draw the dotted lines. From the point P, how much the distance in O to P dash, same distance we maintain here. So, R to S draw the parallel to the air gap line. So, once here the point S is formed, directly attached to the point P to S, we construct the triangle here. Very simple construction. By using this triangle, we can determine the regulation of alternator. Next one is American Standard Association method. This is an extension of 4-tier triangle method. Assumptions are saturation effect is considered, leakage reactants and armature reactants are considered separately. This method is based on the modification of ZPF method, including drop due to saturation effect. Hence, it gives highest accurate result. This method requires mainly two characteristics, OCC characteristics, ZPF characteristics. Already I discussed that one. So, the graph is similar in ZPF characteristics and ASA characteristics. The drop is different. From the 4-tier triangle, we can finding the regulation here, but out of the 4-tier triangle, finding the regulation in ASA method. Thank you.